Hello, everyone. Welcome to another edition of the Carolinas Weather Group. I am Scotty Powell, host here at the Carolinas Weather Group. We have Ricky, who is my co-host, and Kit as well joining us tonight. We're going to be talking about the GOESR satellite. We've been discussing this for a couple of months now. We had Rob Eichler on a couple of weeks ago, and he was discussing a little bit about it. It got our curiosity up, so we decided, hey, let's get some experts on this and kind of talk about it. It's going to be a real big breakthrough for the weather enterprise once it gets launched. I think it's early next year, so we will definitely talk about the launch date and all that's been put into it. Tonight we have two guests on. First of all, Dr. Stephen Goodman. He is a first-time guest of the Carolinas Weather Group. He is actually the program scientist for the GOESR project, so we're looking forward to knowing the ins and outs of this program and exactly what's it's gonna produce for the weather enterprise. We also have Tony Rice on, who is our resident astronomer, weather space person. He has joined us a couple of times before, and Tony's going to be talking to us a little bit about how this thing's going to be launched into space and the ins and outs of that. We had Rob Eichler scheduled on, as you probably seen in the little promos that we've been doing throughout the week, but Rob has felt ill this evening, having some sickness with him, so he's not going to be on joining us tonight, but we want to send our well wishes to him and hopefully a speedy recovery with that. Couple of housekeeping notes. This is a live program, so if you want to Facebook or tweet a question for our panelists, you can do that through the various social media outlets, or if you are listening on a podcast, and a couple of weeks from now, feel free to tweet as well, and we'll try to get that answered if at all possible. I think that's about it, housekeeping-wise. I do know before we started tonight, Ricky did download several of the podcasts from last month, so they are now up on your favorite app store to get to download, so you can listen to at your pleasure. So with that, I'm going to kick it off to Ricky Matthews, who's been gone for the past couple of weeks, and kind of let him talk a little bit about what's been going on the past few weeks for him, and then we'll kick it to Kit, and we'll get started with the show tonight.
All right, thank you, Scotty. Yeah, it's been a busy few weeks here in the Tri-Cities. I've been doing some fill-in work on Thursday mornings for some of our other meteorologists, and then I took a trip down to Charlotte the previous week, last week. So it's been a little bit of a busy time, but I'm glad to be back and hang out with you guys once again. Kit is down where I was last week. That looks like a familiar little spot that I know. He's in our meteorology lab at UNC Charlotte, so if you have any grudges against him, you want to go get him, he's in there. But introduce yourself, Kit, and tell us how everyone's going.
Well, now that the FBI knows where I am, I'm going to have to move mid-chat. So I'm Kit Cloninger. I'm a junior meteorology major here at UNC Charlotte. I've been on the panel for a while, so some of you may know me. If not, hello, welcome. As far as weather, there's been absolutely nothing going on still. Still just high pressure. So, Scotty, if you want to kick it off to the show.
Yeah, we can definitely do that. And I will tell you this, Kid is an avid ultimate Frisbee guy. I saw him playing last weekend. He's pretty good at that as well, so don't let him kid you on that. So
I'm
tonight,
not quite at the ultimate level. It's about moderate Frisbee.
Moderate. Getting there, though. Getting there. Well, tonight we're talking about the GOESR project. We discussed it a little bit a couple of months ago with Rob, and like I said earlier, we are so excited to kind of dig our way into the project, and so we went through Twitter and got some folks, and we got Mr. Steve Goodman on tonight. He is the program scientist for the GOESR project. Steve, good evening. How are you doing?
Oh, I'm doing great. Glad to join you guys.
Well, we're glad to have you, Steve. If you don't mind, tell us a little bit about yourself, how you have ventured through the weather enterprise, and then we'll introduce Tony, and then we'll get into the program.
All right. Well, I guess my story begins University of Wisconsin in Madison. I got my undergraduate degree there. And then we had one of the professors there knew some professor at the School of Meteorology at Oklahoma, and asked if anyone wanted to chase tornadoes. And that sounded interesting to me. I didn't want a desk job all my life. And this was 1977, and we were just developing this new radar called NexRad at that time. And we had one at the National Severe Storms Lab, which was affiliated with the University of Oklahoma at that time. And I started graduate school at Wisconsin, and then I transferred to OU and finished my master's there in 1981. And then got a job as a contractor with NASA in Alabama. I finished up my PhD in 1990, and I spent 20 years with NASA as a scientist. And we began the first ideas for one of our instruments on GOESR 38 years ago. It takes a long time to bring these babies to maturity. And then I've been with NOAA about 8 years in the National Environmental Satellite Data Information Service, working as the chief scientist for the GOESR program since 2008. And our launch date is now October of 2016, and we've been spending the last 10 years developing the instruments for this program, and we're on the verge of getting ready to launch her, and a lot of excitement's building. And in fact, a sister imager of ours was commissioned in July on the Japanese geostationary satellite called Himawari. And you folks may have seen some of the latest typhoon imagery from that satellite. And we collaborate quite closely with the Europeans and also the Japanese and the Chinese over our next generation satellite constellations. And I guess we'll talk more about that as the show goes on.
Stephen, to start off, just so we have a baseline of everything, talk a little bit about how GOESR is different than maybe some of the other things people are familiar with, GOES East, GOES West, the other GOES satellites that are up there.
Okay, so to the first order, it's not different. It's continuity of the geostationary satellite program, and the instruments have been mostly evolutionary, although with the GOESR satellite, it is the first probably dramatic, perhaps revolutionary change we've had in the last 30 years. We've been flying 5-channel imagers with the water vapor band at 6.7 microns, which you follow on television quite regularly, infrared band to look at cloud top temperatures and visible imagery. Over the last 30 years, the resolution, the spatial resolution has improved, starting with something like 14-kilometer resolution, going down to 8 to 4. And today, with the current imager, our visible images are 1 kilometer and our infrared images are 4 kilometers. And with GOESR, that's going to double. So we're going to have 500-meter spatial resolution from geostationary orbit, 2-kilometer infrared, with some of the near-infrared bands, even 1 kilometer spatial resolution. And then a wholly new instrument we've never had before called a geostationary lightning mapper. We've flown a heritage instrument on 2 NASA research missions called the Tropical Rainfall Measuring Mission. You may have talked about that in an earlier program. That mission just ended after 17 years in low Earth orbit. And basically the concept of that instrument is what's going to be on GOESR in geostationary orbit with nominally 8-kilometer spatial resolution, and we'll be able to go nearly wall-to-wall between the 2 satellites in the Atlantic and Pacific from the west coast of Africa all the way to New Zealand. And we'll be mapping what we call the total lightning, which is not only the lightning that goes to ground that we see the optical pulses at the top of the cloud, the light that your eyes can't see during day as well as at night. And then we also see the in-cloud lightning, which is the predominant type of lightning produced by storms. And that's something that is not well seen from ground-based networks.
You mentioned earlier when you first started that this is a really over 30-year process to get this satellite up, almost a generational process for a few scientists who've been working on it. When did it really just start? When was the whole idea to launch this new satellite in? I want to bring Tony in here in a moment too, because he's our resident space guy. He loves satellites and launching things into space. We don't want to let him go. But talk a little bit about the background and some of the leaders who are behind this kind of stuff.
Okay, so yeah, the current system probably goes back maybe 15 years. In 2004, we just started feasibility studies for the new imager. And so the advancement is, instead of 5 bands that we have today, we have 16. And we're able to see all sorts of phenomenon that we currently can't see from geostationary orbit. If any of your listeners yourselves are familiar with a NASA instrument called MODIS, a moderate resolution infrared spectrometer, it has 32 bands in low Earth orbit, and nominally you can think of MODIS in geostationary orbit with 16 bands instead of 32. And so that's part of the revolution. Doubling the spatial resolution is another part of it, and also the temporal refresh is much greater. So right now, if we have a severe storm monitoring call, the satellite will image every 7.5 minutes, and with GOESR we'll image every 30 seconds. We did this for a while on the GOES-8 satellite, but that data never went into operations because we just never had the bandwidth and infrastructure to move such vast amounts of data around to users. And it's still a bit of a concern to do that even with your large networks, but once you have a lot of people sharing the same network, you start carving out parts of that full bandwidth you'd like to have. So anyway, the 30-second imagery is about 1,000 kilometer by 1,000 kilometer footprint, which nicely covers a tropical cyclone, or it can cover a mesoscale convective system as it's moving across the country. So it's spatial, temporal, and also the spectral information. If you multiply that and say I got 5 times the temporal refresh, 4 times the spatial coverage, and 3 times the spectral content, you got a 60 times increase in performance. And there's some other nice features, like we had a recent conference on the 10 years since Hurricane Katrina. Well, during Hurricane Katrina, during the eclipse periods, which runs from roughly February to April, normally 6 weeks around the solstice. So February, April, 6 weeks, and then like August, October for 6 weeks. The batteries were inadequate in order to keep the satellite going when we would have these eclipses. The current satellite, GOESR, we have effectively no timeout during those periods, so we can trend and follow high-impact weather phenomena without, losing context. We just are able to keep it going because the batteries can continue to operate the instruments through that. So that's quite an increase in capability.
Oops.
Oh, I can't hear you.
Got it. We got it back. I've unmuted it. That's something I never even thought of. Comment a little bit on that and explain what the eclipses are, and how satellites go down for that. Or just aren't as operational, or what is it?
Well, what happens is the 2 things happen when you run into an eclipse period. I have some numbers here. So during the GOES-I through M series, for example, when we had Hurricane Katrina, the National Hurricane Center had to use the GOES West satellite in the Pacific to look back towards the Gulf of Mexico, and that was GOES-10 at the time, to complement GOES-12, which was in the Atlantic. And that problem started to be reduced with GOES-13, which is the current GOES East satellite at 75 degrees longitude over the Atlantic, and virtually eliminated. And I think the number is about 72 minutes per day was the outage, because the satellite is in the Earth's shadow. So the sun is one way, then you got the Earth, and then you got the satellite behind the Earth. And being in the Earth's shadow, we weren't getting any sunlight on the solar arrays, and the batteries just can't keep the imager going. So that's why we had a loss of data. And so now we have a resolution to that with the better batteries. The imager is quite large. I don't know if you're able to bring up any of the pictures of the satellite, but the current imager, the 5-channel imager, is I'm trying to think, maybe about the size of a dorm room refrigerator, maybe a little bit bigger. Now there's the spacecraft. I don't know if you can fill the screen with that and get an idea of it. You can see people working around the spacecraft. There you go. So it's out. This is a spacecraft out at Lockheed Martin in Denver, Colorado, where it was assembled. The instruments were integrated, and you can see the size of the spacecraft versus the people. It's about the size of a school bus, and the imagers are up there on the top. It's the Earth pointing part of the spacecraft. So you got the 16-channel multi-band imager, and then the lightning mapper is next to it. That little, that rectangular thing you see there on the top portion, top deck, that's a radiator, and that's to allow the imager to reject heat into outer space so it can stay cool. And so that imager, if you look at, you can't tell maybe from the picture, but it's about the height of a human being versus a dorm room refrigerator.
I never would have thought of that about a satellite. Granted, I don't know as much as maybe Tony, who we're going to bring in here in a second, about satellites, but that is interesting. I never would have thought there's downtime, for stuff like that. Tony, let's bring you in and talk a little bit about how we're going to launch this thing. You mentioned it's a big old rocket we're putting this thing on to get it up to space. Tell us a little bit about that whole process.
It is. Put that image back up if you don't mind. That brought back a bad memory for me, and maybe Stephen will remember the saga of Noah 19.
I think you're thinking N prime falling over, right?
Yeah, it was going into that rotational position there, and didn't get bolted down properly, so it was pretty badly damaged. But I think they did end up repairing it and launched it. That ended up being the flight article.
You can believe that's on everybody's minds when they're moving spacecraft around these days.
Yeah, that won't happen again. I don't think that's going to happen again.
I don't think so.
Yeah, but the period of eclipse is really interesting, and it's just a matter of the physics. It's a matter of the position of the Earth and the Sun, and these are stationary satellites. They're over fixed positions. Stephen, is this going to replace the GOES East eventually?
Yeah, so the game plan here, the official game plan is, so with the current launch date of October 14, 2016, 70 days after launch, which is nominally January 1st, 2017, we turn on the instruments. So we're doing post-launch checkout of the spacecraft and outgassing of the instruments so there's no contaminants that gets on the mirrors and the lenses. And then for the next nominally 4 months, so a total of 6 months since launch, we do our post-launch testing and make sure all the spacecraft commands can be executed and all the modes that you would operate in can be done. And then for the next 6 months, after the first 6 months, first 6 months, NASA, who's doing the flight part of the program, will hand it over to NOAA. NOAA accepts it. And then at 89.5 degrees longitude, NOAA is going to continue another 6 months of post-launch testing, which then would take us to the end of the 2017 hurricane season. And then depending on the health of the constellation, it'll be moved either to the east or west position, replacing either GOES 13 or GOES 15. 13 is east and 15 is west. And then we have GOES 14, which is an on-orbit spare right now at 105 degrees longitude. So if something happens to the current constellation before then, GOES 14 will go to replace the broken one, and then GOESR will go to the other slot most likely. And then the next satellite in the series, GOES-S, they have letters before they're launched and then they get numbers. We'll go to the other position about 14 months later. So if we launch R in October 16, GOES-S, to fill out the new constellation, will be launched in December of 2017. That's the current schedule. So if the constellation is healthy, we're going to retire one anyway. Because of the lightning mapper and all the lightning you typically have over land versus ocean, and if we have a really interesting hurricane season with GOES-R performing as we all expect, then it's maybe perhaps more likely that GOES-R, the first one, will end up replacing 13 in the Atlantic, but that decision won't be made until we get there.
That makes sense, and with the capabilities, and I'm sure we're going to get deep into that here soon, but with the capabilities, it sure makes sense for it to end up over the eastern basin. And not a lot of folks know this, but that eastern position is a little over 22,000 miles above the borders of Colombia and Ecuador. So it's sitting right there on the equator at about 75 degrees. So yeah, we started talking about the eclipse dates, and they're actually kind of wide. I'm looking at a notification that came out from NOAA a couple of weeks ago, and this is for the GOES East. It runs from the middle of August to the middle of October. So that's a pretty wide range that you got to plan for there. But yeah, that is a very big bird, a very big satellite with lots of capability. And I was looking at the planned rocket that it's going to be placed on, and it's an Atlas V, and has a number after it, a 541 number. And what that means is the 5 stands for a 5-meter fairing, which is the largest fairing they put on that rocket. The 4 stands for the number of solid rocket boosters. So if you remember the shuttle program, it had the white pencil-looking solid rocket motors along the side that burns the same kind of fuel. If you ever played with model rockets as a kid, or still play with them now like I do, it's burning a similar kind of fuel. But those are the more solids they have on the side of that rocket, the heavier the payload is, and the more oomph they need to get off the pad. So that's got 4 of them on there, and then it's got that single engine on the second stage. But the last time that we flew an Atlas 541 was actually for the Mars Science Lab. So we needed that much power to get that, basically ton of spacecraft off the pad and off to Mars. So that gives you kind of an idea of how big this weather satellite is.
And after we launch this into space, Tony, where's the data going to come back to? Does it come to Wallops?
Wallops is going to be one of the primary locations that's receiving the data. There's a couple of good-sized dishes there that are engineered to take some pretty heavy winds. I believe Cat 2 when they're operational, and maybe even up to a Cat 4 hurricane when they're in bird bath mode, when they lock them down.
Yeah, I think it's it's either 115 or 125 miles an hour.
Yeah, they do pretty well there, but that's
so we have new antennas there also. We've had to deploy new antennas at Wallops, and then for the first time, we also have antennas at Fairmont, West Virginia.
And that's the backup side, I believe.
Right, we've never had that before. It's a hot backup, and basically it's running all the time, so that suppose a storm came and, like you said, the winds were too strong and they couldn't receive the data at Wallops, then the hot spare at Fairmont, West Virginia, we'd fail over to that, and it takes, I think, 2 minutes to switch from Wallops to Fairmont, West Virginia. And the reason it takes 2 minutes is because for fail-safe, it requires a human intervention. So a human has to go and throw a knob or switch or something, and in order to do the conversion. It could have been all automated, but just to make sure nothing squirrely happens, a human needs to go in there and make that maneuver. So it's about 2 minutes.
I'm picturing one of those cool switches that has the plastic cover on it that you have to lift off of.
Maybe.
Yeah, so talk a bit about, so you mentioned that that hot spare capability. You don't do something like that unless you're concerned about real-time data. Talk about some of the real-time capabilities you're hoping to get out of this spacecraft.
Okay. It'd be nice if we could bring up the GOES 14 hurricane loop that we have. I should mention, I talked about the Japanese satellite earlier. Their rapid scan imaging mode is 2.5 minutes. The European is also 2.5 minutes. Ours, I said, was 30 seconds. And we've been using the GOES 14 on-orbit spare for some experiments to show forecasters what this rapid update information would be like. And you can follow the development of convective storms, outflow boundaries, interactions, and so on with secondary development of storms really well, like you can't do with 15-minute or even 7.5-minute imagery. So we have some beautiful animations from the GOES 14 1-minute data at the University of Wisconsin. If you search on GOES 14 SR, which is Super Rapid Scan Operations for GOESR, since 2012 we've been running these experiments. Let's see, this is August, September. So we just finished 2-week experiment this August, and we've been doing it in the spring to get severe storms, and then in August to get anomaly fires and other phenomenon. And then our next experiment is going to be in February 1st to 25th. There's 2 experiments going on there. One is called Vortex Southeast, which for those who study severe storms are going to do an experiment in North Alabama. We all remember the April 27, 2011 outbreak that went through the southeast U.S. So there's a lot of interest, because the mechanisms are a bit different for the severe convection, to do this experiment. So we've been able to, or we've been granted the use of GOES 14 by the operational folks for that period of time. And the reason we end February 25th is, as you said, it's the eclipse season, and they don't want to run the spare satellite then. So we're going to look at severe storms, but also we're going to look at hopefully nor'easters and winter storms going up the east coast of the U.S., which we've really never done before. So we work very closely with the Weather Service, with NCEP, and the NOAA test beds, and provide them the data in real time so they can put it on their forecast floor and make use of it. So the rapid information, it's mostly to look at the developing convection and details that you can't resolve. Unfortunately, even with GOES 14, we have the 1-minute update, but the spatial resolution is what we have today. It's not the 2x spatial resolution we're going to have in the future. So we can look at fires, for example. You can look at the plumes from the fires, like the rim fire out west, for example, and watch those evolve. The folks who fight fires find that very helpful when they're trying to deploy the equipment and people. So we expect there'll be new applications in firefighting with the new GOES capabilities. I can't make out exactly which animation you got there, but there's obviously a cyclone that we're looking at. And the rapid update will let you see features. What you can't tell is this is just an image, but we can do things with the imagery. For example, you can see on that the cloud motions, your eyes can follow what look to be coherent structures in the clouds as a function of time. And what you're able to do then is track from image to image to image. We need 3 images, and we calculate what we call atmospheric motion vectors, or derived motion winds. And we can track the water vapor band and also these cloud features. And you can look at that image and imagine you're looking at 3 successive images a few minutes apart, and then you could draw a wind bar between them, a vector basically. And we can get what we call high density winds. And those winds actually go into the numerical weather prediction models. For example, the global forecast system uses the geostationary and low Earth orbiting satellite constellation and these derived motion winds to give the model information on winds where we don't have ray windsons. And it has a very big impact. I think the motion vectors are number 6 in rank in terms of information content for the global models. And with GOESR now, with the higher spatial resolution, we'll be able to zoom in on the storm and create at the mesoscale these high density winds. And there's been some experiments done. Chris Felden, for example, the University of Wisconsin has input these high density winds into the Navy mesoscale model, and they were able to get a rapid intensification that was close to observations, much better than you would do with today's models by having this rapid cloud motion information to put in the model. So that's one of the derived capabilities. For example, another fellow, John Mesikowski at the University of Alabama, Huntsville, is taking 1 minute by 1 minute by 1 minute imagery, and by doing the tracers, he's able to calculate vorticity and divergence at cloud top. And as you know, the NexRad radars, we scan every 5 to 6 minutes. So if you want to get the delta T time rate of change of something, you're talking 12 minutes to get one value. Here you're getting a value every single minute. And there could be new unrealized opportunities for these kind of calculations, vorticity, divergence, shear deformation, which the satellites can now do because they update rapidly and have the higher spatial resolution. So that's why we say, I mean, there could be quite a revolution in the kinds of diagnostics we can do.
Tony has brought up an image here, which if we can present Tony's image, we'll let him talk about it a little bit here. You may be muted, Tony. Oh, Tony.
Just trying to find the control. Actually, I was bringing this up to help him make his point about the amount of time that's that's lost in the current generation. And it shows really nicely how much more data is coming down in that 5-minute period.
Which, as he mentioned and you mentioned, have extreme, implications for the future of meteorology. I'm looking at some of your PowerPoints that you shared with us, Stephen. I'm interested in one of the rapid intensification stuff that you mentioned for hurricanes, and how we're talking about the Key West hurricane for today and how it rapidly intensified. Talk a little bit about that, and if we can present that slide too, that'd be great. Let's see if I can bring it up.
Yeah, in the rapid scan, I should mention, when we say 1 minute and I mentioned 30 seconds, we have two different modes that we can operate in at launch. One is called mode 4, and we take 5-minute full disk images just continuously. And then we have another mode we call mode 3 or flex mode, where we can take a 15-minute full disk, a 5-minute CONUS, continental U.S. image, and a 30-second mesoscale. And imagine, suppose you have a severe mesoscale complex squall line over the Great Plains, and at the same time you've got a tropical cyclone in the Gulf or in the Western Atlantic. We can ping pong between the two. We could take a 30-second image in Oklahoma, and then take a 30-second image off the Carolina coast, and then go back to Oklahoma and back to Carolina. And in fact, during our last GOES 14 science test, we wished we could do 3 of those. We actually had a tropical cyclone in the Cabo area in Mexico, the Baja of California. Saw another severe storm over the Great Plains, and then we had another storm on the East Coast. And so you can see why you'd want that mode of ping-ponging between different storm systems that you'd follow as a function of time. So now you've got the lightning up. Did you want me to comment on that?
Yeah, sure, go ahead.
So in developing some of these new applications, Mark DiMaria, who's now at the National Hurricane Center, has done a project where they've looked at, and this actually have been studies people have done for 20 plus years, looking at what does lightning tell you about tropical cyclones, and the results have been mixed. Some results say that, well, when you see lightning in the eye wall, it's intensifying. Other studies say you see lightning in the eye wall, it's weakening. You see lightning in the rain bands, it means one thing. And there's many, many studies using these cloud-to-ground lightning networks that folks have examined. They haven't had the total lightning like we'll have from the satellite, which produces a lot more in-cloud lightning than the cloud-to-ground. But in this example, what Mark's group has found is that just like when you have an ordinary supercell or a thunderstorm, when you have strong vertical shear, the storms will last longer. Similarly, in a hurricane, when you see lightning showing up in the eye wall, what his work has showed is that's an indicator that the storm is going to not intensify because you've got shear. We know that shear is not a friend of hurricanes because it tears them apart. And so when you see the lightning in a particular location, it can indicate whether or not rapid intensification is perhaps beginning or ending, and this would be a potential application. So in Katrina's case, for example, is Category 5 over the Gulf, and then it weakened, although still very destructive with the water, to a Category 3, and the lightning data we think will be helpful in providing additional diagnostic information. There's as you know, there's a suite of models they use at the Hurricane Center, one of which is called the Statistical Hurricane Intensity Prediction System, or SHIPS. And what that is a linear regression of a number of variables that we think are important for intensification of hurricanes or tropical cyclones, such as sea surface temperature, the wind shear, certain attributes of moisture around the system. And what Mark has done is his group's added lightning as another one of these predictors, and they find that they reduce the bias in the intensity forecast by about 10%, which is really quite good. And will that hold with many, many cases and storms that are maybe slightly different? We won't know till we actually have this new capability on orbit, but it's a nice early indication that there's potential value in that.
Right. Reminds me a little bit about Hurricane Arthur when it was coming ashore, and I was down there, and there was an excessive amount of lightning, more than I've ever seen in a tropical cyclone, as it was strengthening as it was still coming ashore, almost a real-time, you've seen it application of something like this. So.
Yeah, we know from the microphysics that efficient electrification occurs when you've got mixed-phase microphysics in a storm. So you've got graupel hail in a nice mixture, rich mixture of water vapor, and you'll get efficient charging. If you have a warm cloud where you don't put a lot of particles up in the mixed phase region, they don't electrify very efficiently. For example, tropical storm, I think it's Josephine, the science operations officer, Dave Sharp at the Melbourne Forecast Office in Florida, told me that storm produced one lightning flash during its whole life cycle, and the one flash occurred when the radar echo just barely got above 5 kilometers or 0 degrees C altitude, again indicating glaciation or the ice phase process occurring in the storm. So when you see prodigious amounts of lightning, you know they're very well developed vertically to produce so much lightning, and they're producing at least small hail at a minimum. And I remember when we first launched the TRIM mission, Joanne Simpson, who's a very famous meteorologist, I believe she's the first woman PhD in meteorology from the University of Chicago. She's chief scientist at NASA Goddard Space Center and the mission scientist for the Tropical Rainfall Measuring Mission. She told me, yeah, I've flown on a lot of hurricane hunters and penetrated tropical storms, and I've seen all this lightning. And she says to me, so why do I see all this lightning, and yet we're up on TRIM and we see with our snapshots few storms that are making lots of lightning? And what we've learned in the intervening 15 years or so is that it can be highly variable. There's a famous storm in the bulletin of the AMS. I think it's Hurricane Earl, maybe. It went over the Dominican Republic. Maybe one of you recalls what storm that is. But it produced prodigious amounts of lightning, and the radar reflectivity core went to 20 kilometers altitude. So when you have storms that are very deep and developed like that, they're going to produce a lot of lightning. Of course, the beauty of the satellite observing the lightning is the radar not only gets a snapshot, but over Hispaniola, maybe there is one radar, I'm not even sure. So think about this. If you combine the total lightning, which tells us about the vigor of the storm, with the high-resolution imagery information, which not only tells us what the clouds look like, but also tells us things like whether a cloud is ice cloud or water cloud at the top, whether glaciation has occurred, what the effective particle radius is at the top of the cloud. Are they small particles, which you might expect if you got a very strong updraft and they don't have time to form, or maybe they're larger particles? All that information can be derived from the new imager on GOESR. And so if I don't have a radar, the Aviation Weather Center for transoceanic flights is very excited about having the lightning mapper and the imager together to give them much better diagnostics on the characteristics of the storms that you're flying across. Since you don't have a radar, maybe it's a poor man's radar, but a lot of good information about the convective vigor of storms.
It's amazing all the applications that you're mentioning, between the aviation industry, the potential impacts just from hurricanes and different types of weather. It's almost like the satellite's being launched mainly for meteorologists, but it almost impacts everyone on Earth in a certain way because lots of people are flying, lots of people, they're staying safe by getting better weather information in flights and stuff like that.
Yeah, I should be fair to the non-meteorology part that we also do a land vegetation index, the veggie product as we sometimes call it.
The NDVI, or is that?
NDVI you can calculate, right? We have the extra bands for that. One difference between the Japanese satellite and our satellite is they chose to have a green band, which extends from 0.51 to 0.55 micrometers. So green, for example, we know blue is in the 0.45. We have green 0.55, red 0.65, so on. So they can make what's called a true color image. Well, it turns out that by their green band isn't quite centered on, quote, the color green in the spectra, but there's also a lot of chlorophyll information that we use like an NDVI to look at the health of plants. It's in the 0.86 band. which we also have on GOESR. And so our scientists have been able to come up with a synthetic true color capability with GOESR. So we take our blue band, which is 0.45 or 0.42 microns, our red band at 0.65, and then the near infrared band at 0.86, and you can build correlation tables between these, and you can do something called a Rayleigh correction, which removes sort of a milky looking backscatter that you get from the radiation that you're imaging, the backscatter to the instrument. And that stuff is just absolutely gorgeous. The only place maybe it doesn't truly reflect what true color looks like is has maybe not the fidelity of getting things like browns in like the coastal zone. Like if you're looking at plankton and algae, ocean color type things, it's not an ocean color instrument. It's made to look mostly at weather phenomena. But it will see land. We also make ice products. We'll be able to map the ice over the Great Lakes for the first time, and the Weather Service is very excited about how we'll be able to do that. You take a passive microwave or an active microwave instrument in low Earth orbit, combine that with the staring geostationary imager, and you can make even more new products that can give you better information on age of ice, thickness of ice cover. We also measure snow cover extent. So there's a number of land surface products that we can generate. We also can retrieve things like smoke and dust. We have a new capability called RGBs, which stands for red, green, and blue. For those of you who have fancy computer monitors, you can adjust the hue and the contrast on your color guns, your red, green, and blue color guns. So if you think of the analog to that, with the red, green, blue channels, we can assign different colors to different spectral bands, and in one image then you can see the smoke and the dust come out. I have one example I gave you of a dust storm there in the western US, and if you apply these recipes or algorithms with these additional spectral bands that pull out the dust, you'll be able to see how well those features show up compared to how they are today, where it's very difficult to distinguish. Yeah, that one there. So if you can bring that one up. Can you make that a full screen? So back up one image. I think you're already seeing the enhancement. Can you back up to the previous slide? I think it'll do a morph into this current scene. Are you able to back up one?
Would you like the greatest?
Previous slide, yeah. Can you back up to the previous slide, and then if you
This is the
now
previous.
go forward.
Okay, that's this one.
Oh, okay. I guess I didn't.
I think it rotates through. I think it animates.
Yeah, there's. Do you have it? It's not. Is it in PowerPoint show?
Now it is. There you go. I think it rotates through because I'm not changing anything.
Okay. Because if you back up, what you see is the red enhancement there, which is the dust from a dust storm. It's very difficult to see that against the gray or white cloud, but when you apply this RGB enhancement, it really pops out at you. And then in the bottom right there is a dust storm with a photo there at the airport, where we've actually had quite a few intense dust storms already the last couple months. So it'll be very good at pulling out these dust features. And again, back to hurricanes, the Saharan air layer, which brings in dust and dry air into a mix with the hurricane, it'll help us to dissect the air masses that are merging very nicely. We can't do that with the current imager. We just don't have enough spectral information with the current capability.
Is this the image, Stephen, the red and green you were mentioning?
Yeah, so yeah, you in the lower right part of the screen, you just notice the very dramatic contrast. That's the dust that's pulled out with the RGB.
I want to pull mine up. I think mine will show the demonstration real quick.
Okay.
So it's been a real challenge to educate the forecasters. This is all brand new to them, to look at and interpret these types of RGBs where you're getting air mass information instead of just looking at the 5 bands we have today. And that's how we're spending a lot of our time. We're already busy developing the training modules that every forecaster in the National Weather Service is going to have to take to become proficient using the satellite data. What the goal is, since we're so radar centric in the U.S. with our wonderful national radar network, which really is unparalleled anywhere else, most of the forecasters rely very heavily on the radar. But now with the satellite having this new capability and the faster update, I think we're all recognizing that the forecaster needs to be proficient, not just in the radar, but now with the satellite as well. And that using them together, what the Weather Service calls fused products, along with combining numerical weather prediction, is the wave of the future. And so there'll be giant leaps, I think, with these new capabilities of the polarimetric radar, the GOESR satellite, and storm scale NWP to really unravel a lot more and improve forecasts and warnings.
There's exciting times ahead, as you say. Tony, I want to bring you in here just because we're getting close to 9 o'clock, and you had a few slides you wanted to show.
Yeah, one of the exciting things about this, one of the exciting capabilities about this particular satellite is not only are these Earth-facing instruments that we've been talking about that have some of the lightning capabilities that we've not seen before, cloud-to-cloud lightning capabilities too, which is awfully cool. I'm hoping we can make good use of that during launch times for other satellites. That's one of the challenges, is finding a hole in the weather where we can get a bird off. But the space weather capabilities are pretty impressive. So this is showing those instruments on board, and there are a number of them that are sun pointing. So this is an image that I see over and over again in any education pieces about space weather. And to your earlier point, this is something that affects not just CONUS, or it's not just North America that this satellite's going to be looking at, but it's going to affect the entire Earth. And one of the big capabilities is going to be measuring those any of the mass ejections that are going to be coming off of the sun, because that can have a real big impact on radio communications, and it can also energize power grids and things like that. So it's adding some additional capabilities, and it's putting it in low Earth orbit at a point that's going to complement a lot of the other NASA satellites that are out there measuring these sorts of things. So here's a couple more slides on that. Stephen, did you want to add anything to that?
Yeah, we have 4 what we call space weather instruments. So we have SUVI, a solar UV imager, and that replaces the current GOES, which has the solar X-ray imager. And the scientists have found that you can actually see the solar flares and the coronal mass ejections, those kind of features, better looking in the extreme UV than you can in the X-ray realm. And so that's the reason for the new instrument. It's very similar. It has 5 of the 6. I'm sorry, it has 6 bands, 5 of which are the same ones on the Solar Dynamics Observatory. There's an instrument on there called the Atmospheric Instrument Assembly. It's got higher resolution than the GOESR does, and you've probably seen these solar flares on TV from SDO, which are just spectacular. And maybe we won't be quite as spectacular as the NASA research instrument, but it'll still be very, very spectacular. The Space Weather Prediction Center will be working with the NESDIS National Center for Environmental Information. Formerly was called the National Geophysical Data Center, and they handle the space weather measurements. So they have the solar UV imager. We have another instrument called EXIS that is doing basically an integration of the features of the sun. So it integrates everything it sees across the full sun disk there you see at the lower left, whereas SUVI is actually imaging just like the Earth viewing imager spatially across the sun. And then we also have an X-ray sensor, and then we have particle sensors, which are shown here in the upper right, which are, I think there's 10 boxes located around the spacecraft, and they're measuring high energy protons and electrons that are used in some of the empirical and now increasingly more physical models that the Space Weather Prediction Center runs in order to do their predictions on whether there'll be communication blackouts or effects on the power grid, as you mentioned. And so these are nominally the capabilities we have today, but even slightly better, I think, than we have today. And the cadence, the update, is at least as good, and in some cases a little bit better than we have today.
And I could see some of these data products being useful for human spaceflight as well, and continuing to add to that data set to help us understand what that environment's like and what astronauts that might eventually make it to Mars might be facing out there.
Right.
Now,
Yeah,
I did have a... Oh, go ahead.
No, that's it. I just agree.
All right. Tony, you'd probably be the best one to answer this, but as far as solar flares, like I always hear that they have an effect on satellites. Is there any sort of way that these new GOES satellites can detect that and maybe shield themselves, or is there some way to prevent them from going down in worst case scenario?
Well, shielding is kind of difficult to do way out there, a couple thousand miles away, but it will give some advance warning. And keep in mind too that the sun is a sphere. It's three-dimensional, so not every flare, not every coronal mass ejection is going to result in energy that's going to make it to Earth. It's going to impact any of those satellites. But having that kind of early warning is helpful. Perhaps some instruments can be taken offline. Things like that. There are a few things that can be done. Really, the field of space weather is, I don't want to say it's brand new, but it's something that has been growing, and our understanding of it has really been growing over the long terms. Where that early warning capability really benefits us is here on Earth, and that's why the Space Weather Center was set up to get those kind of early warning messages out there to allow things like polar air flights. We can make decisions on whether that's the right thing to do or not, subjecting crews to extra radiation, and ships at sea, letting them know that they're going to have some radio blackouts perhaps because of this.
Yeah, the GPS network, of course, is affected by a lot of this radiation, and that happen on occasion. The space weather measurements for aircraft, as you mentioned, is key. And there's also at the Lagrange point, the L1 point, a new satellite called Discover, and that gives even earlier warning information because sun's particles hit there first before they make their way onto Earth.
That's
and so
right.
the whole constellation that's up there, in fact, SWPC, the Space Weather Prediction Center, uses not only the operational satellites from NOAA, but they also use the research satellites that NASA has up there, and they take in all that information they can get.
Hey, before we wrap, I did want to quiz everybody but Stephen, because he knows the answer to this one, but I want to quiz the other guys here. So this satellite is going to be launched from Cape Canaveral, and the other place we tend to launch birds like this from is out at Vandenberg Air Force Base in California. So why aren't we launching it from Vandenberg? Who has an idea?
Trajectory of where it has to go.
Which is?
It's got to go over the, it's a stationary, GOES stationary satellite, so it's got to go into a certain spot.
Okay.
And
yeah, what kind of satellites do we launch from Vandenberg that we can't launch? Maybe I asked my question backwards. That we can't launch from the Cape.
Isn't it the polar orbiting ones that come out of Vandenberg?
You're absolutely right. Otherwise, we'd be overflying places like Raleigh, North Carolina, and I don't want any first stages falling on my house.
I live in Virginia, where that one kind of went astray recently, so I can understand that.
Good job, Ricky. Way to pass the test.
Well, I think he had asked that question before to me when I was maybe back at Charlotte. It seemed familiar, but anyway.
You guys might be interested. I know you're getting close to wrapping up. You asked at the beginning of the show, when did we actually start on this? Well, it turns out last year we started looking at what's after GOESR series. We're buying 4 satellites that take us to 2036. And last year we started looking at what should the new space architecture be, what kind of instruments, And a lot of times the instrument that we have operational was a NASA research instrument that preceded it. So those studies are underway. What that will be, we don't know. There's out there with microsatellites, CubeSats. The Canadians had a mission they proposed called the
world will never know.
The Canadians must have cut them off.
Man, it seems like when we get breaking news on this show, it always does that.
And I was going to ask him to repeat that launch date again too, because that's new information.
I think he's trying to come back in.
He's trying.
8-hour review, and that's very exciting because there's a lot of concern about what's going on in the Arctic right now. And
Hey, Steve, I think we lost you for a little bit talking about the Canadian mission. Could you rewind and go back to the Canadian?
Quick, so we're looking at future architectures. I mentioned CubeSats, nanosats. These big giant spacecraft like GOESR, they're very, very expensive. And the Congress would like to know, is there a way to do stuff cheaper? And with the greater concern over the Arctic, you know, President Obama is up there right now looking at the effects of climate change. The Canadians proposed this mission, Polar Communication and Weather Satellite. So it's to give you communications over the polar regions where it's very poor, and also to give you weather and sea ice thickness and the clouds and so forth, which could be imaged quite nicely from what's called a tundra or highly elliptical orbit. Very future constellation. So instead of go and polar, you might imagine an architecture in the future, which would be the international architecture that everyone's contributing to, which would be quite interesting. So stick around for 2036. I don't know if I'll be there to meet you.
Stephen, if I can, we have two questions. First off, if I can ask you to turn off your webcam real quick and just turn off the little video thing, that way we'll conserve a little bit of bandwidth, and hopefully you wouldn't drop off just a little bit as you were earlier. Tony has a question that what's the October 2016 launch date for this? And then I'd like you to recap real quick when we can expect these products to be rolled out. You've mentioned the year or so of testing. When may we see the first operational product? When can I see the first operational product from this satellite?
First light's going to be roughly in January of 2017, and some of the early experimental data is going to go out to the Weather Service for their use. It's basically user beware because there may still be problems with the instruments. They needed more optimal calibration, and so the instruments have not been fully calibrated for operational use, but the experimental data will be available increasingly starting in January 17, going into the summer and fall. And you can bet the Weather Service is going to want that to be as good as it can be by the time the hurricane season rolls around.
And what's the launch date for October 2016?
Right now it's October 14th.
Okay.
We're expecting 15,000 people coming to the Cape in order to watch the launch. It's going to be right at dusk, so it should be real pretty and impressive.
And again, that's a big bird, so Ricky and everybody else, let's make plans to go down there.
I'll be pitching it to my station already. We should go do a story on that. We went to see the space shuttle launch once, so we should send someone down there.
I got a present for you. It turns out we're currently planning to have some teacher education workshops, a broadcaster workshop, and also our scientists will be presenting during launch week. So we have a number of events that will be going on down there. If you're a TV broadcaster and you have an interest in going, send me an email, and I'll send your name up onto the list as they're trying to organize that. Dave Jones from Storm Center, used to be NBC4 in Washington, D.C., is helping us organize the broadcaster workshop.
Sounds good. I'll shoot you an email very soon. So, Stephen, how can people get in contact with you? And then we'll let Tony plug his social media accounts as well.
All right. Well, thank you all for the opportunity to brag about GOESR.
Is there an email or something people can contact you at if they wanted to know more?
Yeah, Stephen, STEVEN .J. Goodman, GOODMAN @NOAA.gov.
All right, excellent. And Tony, you're on Twitter at?
Sorry, my stupid mute wouldn't come unmuted.
I set it up and everything.
You did. That was an excellent toss, and I just missed it. I'm at RTP Hokie, Hokie, and my automated account is at Mars Weather Report, MARS WX Report, and I just got the latest download from the rover, the high on Sol 1091, which was, what's today, 2nd? So that was yesterday. The high was -5 Fahrenheit, and the low was -106 Fahrenheit, and pressure was just under 9 hectopascals.
Boy,
So it's very
suddenly
balmy.
that -13 here last year in February doesn't seem as bad.
That's cool. Quite the spread of temperatures, by the way. Well, guys, we appreciate you coming on tonight. Tony, as always, we look forward to having you back on. And Stephen, man, maybe when this thing gets launched off, we can get you back on and kind of talk about the process and maybe talk to you right before it gets launched.
Alrighty, very good.
All right,
Yeah.
Thank you
Stephen.
for inviting me.
Yeah, no
Alrighty.
problem. We're glad you were able to join us.
And
All right,
Scotty,
thank you.
I'm looking at the dates of January 2017 right now. We might could have Steve. We might could have you back on January 4th, just right before or right after it launches.
All right, y'all take care.
That sounds good. Thank you, Stephen.
Alrighty, take care. Bye.
All right, guys. Well, I hope you learned a lot. That was great, and we got the PowerPoint project or PowerPoint presentation. So I hope you're able to follow along with us tonight as we are trying to present it, and some good information about the GOESR. I'm excited to see what it's going to give us in the weather industry. I think it's going to really help out in a lot of ways, and it's pretty cool to see all the attributes it'll have for space weather as well. So looking forward to that. And we're going to keep on the satellite radar theme for next week. We're going to be talking about the danger zone in North Carolina, the Raleigh, or I'm sorry, not Raleigh, Greensboro, Charlotte area, kind of in the middle between two radar sites. And there's been a big push in the state to get a new Doppler radar somewhere put in central North Carolina to adequately cover the Charlotte metro area as well as the Greensboro area. I about said GSP, but the Greensboro area. So we're going to have Brad Panovich on and Steve Udelson on to talk about that. And after that, we're going to be talking about a few hurricanes back from 2004 that hit the area. So a busy month in store, the month of September. So we hope you will want to join us in the next few shows. I know next week I'm really looking forward to that. I think it's going to be an interesting topic, something that's been of very hot debate in the Charlotte area, at least. Ricky, I know you have a little inside, or not little inside story, but kind of a know of what's going on there.
Yeah, it really has, and there's a little bit of progress being made on it, exciting progress. Hopefully the whole vote that's coming up in early September will make progress on it. I talked a little bit with Eric and seen the letters and stuff that he's written out to some of the congressmen. They're really great information, and he did a great job on getting that out. Tony has sent us a link. I've actually been looking at that a little bit earlier. I want to make sure we throw this in because it does have a ton of good information, as he mentioned. If you want more information about GOESR, go to www.goes-r.gov. There's a ton of information on there, stuff about upcoming events, more scientific stuff than you'll probably ever want to know, a calendar about GOESR. You can connect with them, Twitter, Facebook, social media, stuff like that, pictures, and much, much more.
Good stuff. And Tony, thank you for coming on. We're going to have to wrangle you back in for something exciting. There is one question I wanted to ask you.
Shoot.
And I mean, this has been going around Facebook, and I'm quite upset
here
with
it
you,
comes.
Tony.
I think I know what's coming.
27 moons?
Tony, you haven't told me about the 27 moons that's going to be visible. I mean, come on. You're my go-to guy.
Yeah, we're trying to keep it a secret. This came out of a twin. Well, actually, the first one of these that was floating around social media was 3 or 4 years ago, and it was Mars was going to be as big as the Moon, which we all know is absolutely impossible. And then it was double moons, and then it was double Mars, and then the one that's been showing up on my Facebook feed is 27 moons, and then the Death Star, and it just gets more ridiculous every day. But that at least gives me a little encouragement because people are finally getting it that these things are total hoaxes, and no, you won't see 27 moons anytime soon.
Man, I was looking forward to that.
But before we get rid of you real quick, Tony, we'll talk a little bit about the lunar eclipse we have coming up very soon.
Yes, we have a lunar eclipse that's going to roughly coincide with a supermoon. We all love the supermoons. So that's going to be a particularly big one, 14% bigger roughly than some other eclipses. But that one's going to be visible anywhere that the moon is visible. Lower in the sky, it might even have a little more color to it as you're looking through more atmosphere there. So that one's going to be really exciting. And if you're in the Raleigh area, in the Triangle, the Moorhead Planetarium is going to be hosting a skywatching event the night of the eclipse. And right out there on the sundial in front of the planetarium should be lots of fun.
Now, when you say that,
let me double check that before I get it wrong.
That's what Google told me, so going with that.
now when you say that it's going to be 14% bigger, is that really noticeable, or is that just
absolutely not? But I've learned to love the supermoon because people get excited about it and they get outside and look up. So that's good enough for me.
Sounds good.
But yeah, it's the 28th.
Very cool. All right, Tony, appreciate it, man, and we hope to have you back on really soon. Maybe something cool will happen or something that's upcoming that you can inform us about. We'd love to have you back on and talk about it.
Will do.
All right, Tony, have a great evening, and are you ready for Virginia Tech this week?
I'm ready for college football to start. I wish it would start with a little more certain of a game, but let's get it started with Ohio State and see what happens.
Even Charlotte's playing this weekend. We're playing in some game down in Georgia, which I don't really know about too much, but apparently we're down there.
Yeah.
So.
Yeah, we're actually playing in the Georgia Dome for the first time, and one of the on-campus clubs is taking 100 or so people down to go see it, and then on the bus to go.
Is that on TV, Kit? Are we on TV?
Yeah, it's on ESPNU, I believe.
Ah, okay.
So that game will be.
That's not too bad.
If you're in the Charlotte region, they broadcast the home games on WCCB.
Our good old folks at CCB.
Hey, Tony, I'm telling you, last thing about college football, you did the unthinkable last year, so why not do it again? Start off this year with a bang.
Why not? If anybody can do it, my Hokies can do it.
That's right. Go Vatek. All right, guys, have a great evening, and we look forward to seeing you next Wednesday. Until then, stay safe, and hope you'll join us next week.